Welcome to this Niagara Basics tutorial. In this tutorial we will just go through some of the basics of Niagara systems, talk a little bit about it and just get a general feel for it. So let's jump into it. So here we are inside of Unreal Engine 5. This is a third-person template if you want to follow along today. Now this will be done in Unreal Engine 5, but this works just as fine in Unreal Engine 4 as long as you're using a version where Niagara is implemented. Depending on the version, it might look similar or different, but it's as long as you're using one of the later versions, it should be pretty much one-to-one everything. So, what is Niagara? Well, Niagara is the new particle system in Unreal Engine. It's meant to replace the old system called Cascade. It is more powerful and flexible and modular. It is a very impressive system. Niagara is built on the concept of a Niagara system and Niagara emitters. A Niagara system is an actual particle system that you can place in the world, like for example this one. So you can see it gets a burst when it gets played. An emitter is a component inside a Niagara system that handles one specific visual effect. So if you imagine something, for example, the sparks and the effects of a welding torch. You could have one emitter that is the actual welding torch flame. You could have a different emitter that would be the sparks that's generated by the welding torch. And you can have a last emitter that handles the lighting effects of the sparks, for example. That is 3 different emitters, but you could all bundle them together and then have them in one Niagara system, which would be then the whole effect. And the emitters would be each individual part. So when we open up a Niagara system, this is what you're greeted with. So you have these nodes in what looks like a blueprint background. And each of these orange nodes, or orange-brown, represents one emitter. So this specific Niagara system has 3 different emitters in it. The whole content inside of here is what makes up a specific Niagara system. The Niagara browser or tool, you can see here we have on the left hand side, that is our sort of viewport example. It will display what our Niagara system effect will look like currently. In the bottom you can see a timeline that shows us how far along we are in playing the particle system's duration. On the right hand side over here is where we have our details. So if we have something selected like one of these emitters, then we can see details about that specific thing. There are some things that you should be aware of to make things a little bit more easily understood inside of Niagara. One of those things is that Niagara has 3 general categories. There's the system-wide information, which is everything color-coded in blue. So this node over here represents the system. And you can see over here we have something called system attributes, and you can see that they all have this blue system tag next to it. So system is represented by blue. And inside of this, you can also see that we have something that I refer to as groupings, which is these rows that are slightly lighter gray and has a plus sign next to it. So we have 3 of those groupings in here, and each of the groupings can have 0 or multiple modules inside of them. So for example, the system settings has 2 modules underneath it that belongs to this specific grouping. System spawn does not have any modules currently that we can see. System update has 1 module under here. And that is the first category, the blue one, the system one. Moving on from there, we have the orange-brown category. So if we go to this one, you can see this one is an emitter. And the brown color represents the emitter-wide settings. So on the left here you can see that we now have emitter attributes that are available to us, and they are color-coded the same way. So for example here you can see that we have some system ones, some emitter ones and some particle ones. And the particles are the third one, and that is the green category. So we have the blue for system, orange brown for emitter, green for particles. And all of these things have their own space which within they can have information. So for example, you can see that we have a bunch of things here. These are all variables within the system. So the system age is one variable, but in addition to that you can see that also emitters have age as a property, and particles also. So all of these things have the same property, but they're on different spaces. And then you can also see that they have completely different ones as well. Like current loop delay over here, current loop delay over here, but no current loop delay on the particle level. And why is this good to know? Well, when you look at something like this and you go over here and you see, okay, well, we have only blue groupings in here. That means that these are all system related groupings, and we have system related modules on them. If we go over here to this emitter, you can see that we have some groupings that are orange, we have some groupings that are green, and then we also have some special cases, which is the render and the event handler, which we will not be covering today. But so you have an emitter grouping over here, which is emitter spawn. You have one that's emitter update. So in here you would put in modules that are related to the emitter spawning and the emitter updates. And here you could have modules that are related to the particle spawning and to the particle updates. So these are all different and will have different things to do. You could, for example, have something that updates an emitter or a particle in the particle update or emitter update, and then move it to a particle spawn or particle or emitter spawn grouping. Not every module is able to do this, but some are, and that means that instead of updating something every tick when a particle update or an emitter would update, you would then instead have that logic in the spawn, which only happens when it creates the emitter or creates a particle. Now, there are some basic navigation when it comes to these. For example, you can see that we have this display of our emitter over here, what it's going to look like. We have these checkboxes on top of each emitter. Unchecking one of these checkboxes will omit that effect from this display. You will see it as it didn't exist at all. So now you see we still have a burst here with some trailing after it, but the burst over here is from this one and the trails are from this one. So if we click this one back again, you'll see that we will have considerably more bursts available to us in this preview. If we were to, for example, unselect this one, let's start by unselecting this one first. So if we were to unselect this one, we would lose the trails from our effect over here. Let's give it a little bit more view. So you have these trails here, and if we uncheck this one, we can see that the trails are no longer there. But if we were to instead uncheck this trail leader here, you would see that we no longer have any effect at all. And the reason for that is that these two are combined. They are working together through events. And this one is acting as, like it says, the trail leader. It's the particle that is leading, and this one is creating a trail after those. So if this one is not created, then this one is not created. But in addition to these checkboxes, we also have some other things. We have this little character over here, which will isolate an emitter, so you will only see that one. So if we were to check this one, we would see the burst that's related to this one, but we would not see the other ones. But unlike what happened when we unchecked these ones, we can do something like enable isolation for the trail one, and we will still see the trails even though we don't have the trail leaders being shown anymore. The logic is still running for this one, so we're getting the trails, it's just that it's not displaying them. So these are different ways to make sure that you can look at your effects and see that they are appearing as you expect them to. So I have spoken a little bit about modules. Let's take a look at what a module is. So in this emitter, we have talked about these groupings and that they have modules under them. Let's click on one of them. So color, for example, here. So when the particle spawns, it will determine that it should have a color. So then you see we have some parameters over here, and these we can edit. So we can pick something red, for example. And you can immediately see that the parts that belong to this emitter now are spawning as red over here. So this works similarly to the other emitters. You have these checkboxes next to them. So if we go in here and uncheck the color now, for example, it will no longer have this color attribute module applied to it. So it will go back to whatever the default is. So this way you can actually check and see what the effects of the different modules have without deleting them as well. In addition to selecting one of these modules and getting its details over here, you can see that each of these modules have different details available to it to edit. If you were to click on something like the particle spawn here, you will get all the modules that belong to the particle spawn here. So we can roll all the way down here and find our color, for example, and change it to blue if we wanted to. So that's why I call them groupings, because they encapsulate all the modules beneath them. Equally, the overarching hierarchy for that and groupings would be if you click the emitter, and then you can see you actually have all the groupings and all the modules and everything available to you to edit if you would prefer to do it this way. Generally, it's, in my opinion, easier to find the specific one you want, so you have all the parameters available to that specific module, so you can edit them and work that way. Now, how do you add and remove modules? Well, that's actually pretty easy. You just pick a module and then you remove it by clicking delete, for example. So in this one we have gravity, force and drag. So if I click delete now, actually it can't be deleted because it's inherited. Let's remove this one, so the color one. Right, my bad. I did some playing around with earlier. That was actually a bad way to test this then. I have this as a singular external emitter, which we can see over here. So this is the system, and this is the emitter. And as a quick side note, to create systems and emitters, you go to the FX part over here, and you see you have a system and you have an emitter over here. So this is actually the emitter that we have in the other system. So this one is used in this burst over here. So if we were to go to one of these which are not used, these are not emitters that are standing outside here. So here I could actually go and remove drag, for example, if I wanted to, and then you see that we have a slightly different behavior, because drag is the friction that's caused in air on particles. To add a new module, we go and click on one of the plus signs to one of the groupings we want to add it to. So if we wanted to add drag back here, we can type in drag and then we get it added back again. Sometimes when you add modules, you'll get errors over here. It will say something like you need to do something to have it, it won't work. You'll get warnings or errors. For most cases when it comes to Niagara, it will also include a fix button. So in some cases it might be something like this module over here, solve forces and velocity, needs to be in a certain place for it to work, because these emitters work through their modules in a iterative linear fashion. So if this one was in the wrong place, like for here for example, then that might have caused some other things to not work properly. And then you would get an error. And if you click the fix button, it would move it to the correct position for it to work again. So generally Niagara is very helpful when it comes to errors that you might cause by adding modules. As we have now talked about modules and groupings and emitters, let's talk quickly about this. The render grouping is the grouping that actually represents what you are placing out into the world, the geometry that you're creating. And when it comes to the geometry that it can create, if we were to delete this sprite, alright, again, this one I can't edit because of that. If we were to remove let's go with the ribbon render over here. If we remove this one, like so, we will no longer get our trails after the white particles over here, which are the trail leaders. But we can add something else if we want to. And these are the different types of things that we can render. So a sprite render would mean that we draw a two-dimensional image in the world. Generally, these are billboarded, meaning that they show they're facing directly towards the screen, so that you don't actually notice that they are a 2D image from the camera's point of view. And this is generally used for things like smoke and dust and things like that. The next render here is the ribbon render, which is what this was actually to begin with. And the ribbon renderer uses a mesh, what's it called? When you cut into something, I can't remember the word right now, but when you cut into something, you get an intersection of it, sort of thing. It creates a trail of those in sequence after each other. This is generally used for something where you want to have a trail after something. So it can be used for weapon trails or dashing trails or fireworks that have the trailing after the fireworks and similar things. It's something that leaves a trace afterwards generally. A mesh render is something that will actually render in a mesh into the world. It can be something as simple as a box or a plane, not an airplane, but a two-dimensional plane like a sprite. Or it can be something as complex as a character or something along that nature. Anything that is a mesh, basically. The light renderer is used for emitting lights. Now you have the opportunity to have some particles be emissive so that they look like they're giving off lights like that. But in general, you would have like in the example earlier when we were talking about the welding, if you have the sparks there, you might have the sparks that look like the sparks, and then you might have another emitter that is actually the light for the sparks. And because maybe you don't want, light might be a bit computationally expensive sometimes, so you might not want to have all the different sparks emit lights, but have like maybe half of them or a tenth of them emit lights. Then doing it this way would still give the impression that they're giving off lights, but not be as expensive, for example. The component renderer, I don't actually know myself what it's used for. I will study this at some point and get into it. For now, I cannot explain this for you. The other exception that we talked about, that was another grouping, is the event handler, and we won't be talking about this too much, but as a general concept, this is a way for your particles to communicate with each other. So over here you see we have an event handler for source location event, and then you can see that the source is ribbon trail leader, which is this emitter over here. And you can see like triggers and what it's supposed to do in conjunction to this. So this is how you can have different particles interact with each other. For example, you can have a particle that hits the ground, like a rain particle, a droplet, and then when it hits the ground you maybe want to draw a sprite on the ground that gives the illusion of the water droplet hitting the ground. Or you might want to have something like a fireworks emitter that's shooting away the rocket. Then at some point the rocket explodes, and then you have another emitter that actually takes over and is the actual explosion. And it would then take the position, for example, of the fireworks when it exploded and make sure that it plays out that explosion at that point. So that is the purpose and the general concept of handling events. and it is a very powerful tool, and you can do a lot of stuff with it if you want to. Going back to modules again, each of these different categories or groupings have a predefined amount of modules available to you. So for example, when it comes to this omnidirectional burster over here that is bursting out these blue particles, it has a sphere location on it. Or, sorry, let's take this ribbon trail example instead, since this one I have made outside and can't change unless I go into this one and change it here. So in this emitter, we have, for example, sphere location. Sphere location is a module that defines a sphere in the world in which where you can spawn the particles. So if we were to disconnect this one, you can see that they're all spawning in the same spot, and then they're getting different velocities upwards. So they're basically just going up and then falling directly down. The reason why it would look differently here with this enabled is because they get different positions in the world where they spawn, and therefore have different velocities in different directions. So if we were to remove the sphere location here, for example, we can type in location again, and you can see that we actually have a bunch of different locations available to us. We have a box location, cone location, cylinder location, grid location. All of these are different ways of spawning different things. So if we were to pick the box location now, it will instead spawn in a box that is defined by these parameters over here. So we have a box size. So if we were to make this one smaller, like 111, then we would have a very small box in which they would be spawning inside of. If we had 1,000 of each of these, we would have a 1 meter box that it would spawn inside of, and we would rarely get to see the white ones because they are, I zoomed out a little bit here, so you can see some of the particles spawning out in the corners. If we go to the spawn burst, you can see with spawning 10 particles currently of this one. If we were to do 1,000, you can get a better view of how big this box is that is currently spawning inside of now. And if we go back to our box location and we reduce this to 100, 100, 100, you can see it pretty much encapsulates the whole box and spawns inside of it now. So these are all the modules that you have available to you in the different groupings, and all the groupings don't have the same modules available to them, because a module can be defined as what kind of grouping it can belong to. So if we go back to our third person character again here, you can see that if we go to FX, we have something called Niagara module script. And if we were to do Niagara module script and then just type in test and open that up, you can see that this is what we get. And this is where you can get some real creative freedom and do some pretty advanced things in Niagara. So this can be a module in your system, and it's defined by where you can use it in this module usage. Actually, I'm not sure what is it. Bitmask, okay. Module usage. So this is where you can define. So you can see it's going to be allowing it in the particle spawn, in the particle update grouping, particle event, particle simulation, and so on. So by adding or removing or putting different categories here for it, that determines where you can use it in your different emitters. And then inside of these, you can make use of a lot of logic and do creative things that you need to. It can be anything from having a sword mesh and then picking a random location in a triangle or vertex on that mesh and then generating a particle at that point, or it can be something like we've done in the previous trail tutorial, where we changed the rotation or phasing of the trail ribbon, things like that. So it has an input and an output, and in between here is where you put the logic, and then you have available to you different parameters that you both send into this module and that you might have available inside of the emitter that you place it. So that's how you create a new module, and then you can just add it here by typing in either the name, or you can have a category here and you can name the category, and then you will have it appear under that category. So all of these are different categories that it would appear under. So that's how you create modules. You can also do module creation through scratch padding, which is like a on the fly sort of thing. So you can add a module here and then you can call it test module. And then you see that you have exactly the same layout here, and you have the access to the different attributes here as well. So you could create it here and make use of it inside your emitters as well. This is something, all of these things are things that we will be returning to in more detail in future tutorials. Just want to touch on it very briefly. So a good idea is probably to play around with it and play around with different modules, change the values to them and see what kind of effects it has, and just like toy around with it like a little toy box to get some feeling of it. Of course, in-depth tutorials are also useful to get some creative juices flowing and get some inspiration to what you can do, and we will be getting into that also in the future, of course. Before we do that, there are a few more things I want to touch on really quickly. Just very simple things. So one of the things I wanted to touch on is, for example, if you have, let's take and add a particle spawn and say color for this one as well. Now this one can say I want to have a specific color at spawn. But you also see we have something called scale color over here. That means that during the spawn we can see that the color should be, for example, let's make it something red so we can clearly see it. So if we zoom in here a little bit, like so, you can see that we have the red color spawning at spawn time, or created at spawn time. But we also have a scale color over here. And this one allows us to adjust how the color is supposed to look over time. Now this specific one you can see here is scale alpha, so it's just scaling how transparent it is, so you can see that it slowly fades out as it's progressing in life. So that means that the alpha is going to be 1 at time 0, and the alpha will be 0 at time 1. And time 1 represents like 100% of the age of the particle has expired. But we could equally do something like this for our colors. So we could go and change that. Sorry, I had a bit of an interruption there. So yeah, so this is where you can change things like having the colors change over time, for example, if you wanted to have it scale or change in some way. And you can also bring in your curves, like this curve over here. You can work with it here if you want to, or you can bring it over here by clicking this little show curve in curves tab. If you want to work with it here, it's making changes here, and changes here will reflect in both sides. And there's a lot of flexibility when it comes to things like changing the values of different things. So in this case we have changed it to have a spawn burst of 1000, for example. But we could instead do something, we wanted to have something more random. We can say type in range, then we get a random range of integers, and then we can say what's the minimum value it's supposed to have, what's the maximum. So we had 1000 before. If we bring both of these up to 1000, then we will be getting 1000 each time. If we wanted to have something more dynamic, we could have like 20 to 80. You can see that we have difference each time. So you can change it like that. And these kind of transformations are available to a lot of things. So you can really do some pretty advanced things by changing things into random intervals and creating curves out of them and having a lot of control. So this is also a very good point to play around with and see what you can do. Again, this might be a little bit advanced. It might feel a little bit like what is available to me. So at some degree, I think it might be worth to check out some tutorials and see what they do, because not all of these make sense for all values, and also it might be difficult to realize without having seen it done what you can make use of. But just know that this is available, and this might be a little bit tricky to get the hang of in the beginning, like understanding why can I do this and why can't I do this and such things. But yeah, just so you know. Yeah, I think we have touched on enough of things for now. We will be getting more deep into details later on, but I hope that this was understandable and easy to follow along with, and then we'll get into some more cool things when it comes to Niagara in the future. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.